Okay, here we are in 3.1, and I want you guys to look at this sample one that talks you through the steps of a pretty basic proof. Continues on to page 141, and then turning to look at sections from the exercises. These 4 triangle congruence problems are all pretty useful, and I'm going to show you just a couple of background things related to that. Okay? Okay, so I'm just going to show you 2 quick proofs, or perhaps non-proofs, depending on whether they work out, about triangles being congruent. Sometimes you're asked to prove something that turns out it doesn't work. Our basic tools for proving triangles are congruent are these 4 properties: angle, side, angle, 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 side, 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 and side, angle, side. Now, you can look and see which ones are postulates and which ones are theorems. In a general sense, it doesn't matter. You start with one and you can prove the others. But these are our 4 reasons, and only 4 reasons, for proving triangles are congruent. Things that don't work to prove them are side, side, angle. That does not work. And angle, angle, angle does not work to prove something is the same size. It will be okay to prove that it's the same shape. So this is a proof of similarity, it's called. That's the symbol for similarity, but not for congruence. That's the symbol for congruence, an equal sign with the wavy above it. It is not approximately equal. It is in geometry exactly equal. That's what that symbol means. Alright, so we're starting off with this diagram here, and we've got this shape, and we know that BC is congruent to CD. So I can mark that right there, and I can mark that right there. But when it comes to this one, that's a given, AC, that's that length, is congruent to CE. And we can't easily just mark that. We could do a little brackety thing up here and say that these are equal, or we could put numbers or somehow to show that they're equal. But better thing to do when you're trying to show triangles are congruent is to separate them. Now it looks like we could try to prove that this small triangle is congruent to that one, but these marks don't refer to anything down here, and all we'd have is like vertical angles right here, so that doesn't help us so much. So it's better, I think, to separate these triangles like this, and this one is then A, C, D, and this one then is B, C, E. And then we can mark that this side, that's this one right there at those 2 marks, and this one right here, they're congruent. And then AC, that's this one with 1 mark, is congruent to CE, that's that one. Well, these 2 triangles, to prove them are congruent, we have to find one of these 4 properties up here that works. And of course, you might notice that this is an overlapping angle. It's the same angle. Angle C right here is congruent to itself. And so by reason of side, angle, side, and side, angle, side, these 2 are in fact congruent. So you'd say then that triangle ACD is congruent to triangle, and you want to get the letters in the right order, ECB. And that's for reason of side, angle, side. Now, it's important to notice, for instance, that if you have a triangle and you've got this marked and that marked, this is not somehow side, angle, side just because I'm going in that order, going this way. You have to have the included angle, this one over here that I'm shading in. That's the angle that you must know that's trapped between the 2 sides that you know to be a true side, angle, side. Okay? So if we look at this one, this shape here looks like these 2 triangles should be the same exact size and shape. So if that's true, we should be able to separate them and then match them up with one of these 4 reasons here. So if I draw this like this, and I put A and B and C, and then A and C and D. Now these arrows here show that they're parallel. Well, anytime you have parallel lines, you're going to have alternate interior angles be congruent. So this angle right here is congruent to that angle right there. That's okay. And this length is going to be congruent to itself. So I'm going to put 2 marks there and 2 marks right there. And this side here is given, I didn't write it down, but it's marked as given that this side with 3 is congruent to this side as 3. Well, if these triangles are congruent, it should match up with one up here. And if you see, this is side and then angle over here and then side. I do not know this angle right here, and I do not know that angle right there. And it is definitely not alternate interior angles, because these are only alternate if these are parallel, and they are not marked as being parallel. So if I extended this line and then put my compass point down there and my pencil end here, I could swing another arc and it could hit over here, and I could draw another side that's the same length, because this is all part of a big circle. And you can see that this triangle right here is clearly too big to match up with that one. So like I said, if I extended this side and I swung an arc over here, this triangle could change its shape and it's not going to be congruent. So this is proof that this side-side angle does not work. So this is not congruent. Okay?